see, and we're going to walk through that step by step. Don't expect them to give you a problem that will already have the equations done, although about 5 of the exercises in the homework set, by the way, in this section there's only 10 exercises in the homework set, about 5 of the problems have you do nothing but start with the equation and the constraints and do something with them. So about half of the problems, they give you this. And they tell you that they want you to find a maximum or a minimum, and they don't give you places to do any of the intermediate steps. In this last exercise set in linear programming, none of the problems online ask you to do a graph. But you are going to have close to 0% success if you can't do a graph. So given this system, first thing you're going to expect you to do is to be able to find the intercepts. Letting x equal 0 and letting y equal 0. If I let x equal 0, it gives me the x-intercepts and the y-intercepts, x and y being equal to 0, and that gives me one of my 2 shaded lines, or one of my 2 lines. Finding out where the second equation interacts with the x and y axis, finding intercepts, that's all part of this being able to graph linear inequalities and graph linear systems. So that gives me the red shaded line. And then there's going to be 2 other things that you're going to have to consider. And I'll tell you right now that when you're building your problem, if these 2 statements are missing, you lose all 3 points for the constraints. Those 2 pieces of information, x being greater than or equal to 0, tells you that you aren't going to be able to use this side of the graph. You're going to have to use this side. So if there was a graph problem, that would limit your shading so it wouldn't go into the second quadrant. And then this line that prevents you from going into the fourth quadrant. So those must be present as part of your constraints when we do the word to table setup and build across from there. Now, once you get this particular point, there will be, and they will start you off initially in the first 4 or 5 problems, they will start you off with an objective function and tell you that they want you to minimize it or maximize it, which means that they will give you the objective function. Your objective is no longer to find just the shaded region. The shaded region is called the feasible region, and that holds all the solutions that could exist. We're now interested in finding out the maximum amount of money that we can make out of building fire truck engines and go-karts or something like that. Trying to find out the minimum amount it's going to cost us to ship packages to a certain place. So our new end result is going to be a new objective, and that objective function is given to you for half of the problems in the exercise set, not given to you for the other half of the problems. You have to weed them out. So this would be the end of your first part of the problem. Now, once we have the graph done, we need to find the feasible region. So once again, to refresh our memory about how to find the feasible region, because we've restricted access to not being outside the first quadrant, then we know it either has to be up here, in here, or down here. That means you are going to have to do some point testing to find out which ones will satisfy the conditions of your problem. The 2x plus y being greater than or equal to 30, and the x plus 2y being greater than or equal to 24. And about the only way you can do that is to start picking points in each quadrant. For example, in the upper right-hand region, you might pick a point that you can drop into these 2 equations or inequalities and find out whether they satisfy them or not. I might use the point 24 and 30. The only reason I used the point 24 and 30 was as an easy point for me to be able to read, because all I did is I squared off where the y-intercept and the x-intercept went. You could have picked a point that would have been down here. You get to pick the point, but it has to be clearly in that region. If I was going to check this region next, the upper right-hand region, the upper left-hand region, if I were going to check this one, then I might pick a point that's going to be in here somewhere. I might have chosen 3 and 16. Sometimes those points get a little bit tricky to guess because as the region gets narrower, it's harder for you to pick a good point. If I wanted to check this region down there, I might have picked a point like 3 and 4. If I wanted to check this region out here, I might have picked a point like 18 and 2. But I have to start checking, and I might find it on the very first try. Nothing says you have to start in this order. You can pick any region that you want. But you could, at the absolute worst, have to do 3 points to be able to nail down the correct region. And all 3 of the results you got from those points might be the wrong answer, but if there's only 4 regions and you eliminate 3 of them, then you know the last one has to be the right region. So here, I chose to try the upper right-hand corner first, or the upper right-hand section, okay? So I chose to choose this point, and I dropped it in the problem. The question then becomes, is 2 times 24 plus 30 greater than or equal to 30? Well, pretty obviously, because 2 times 24 is already 48. So it doesn't need any help from the y value. It's already gotten you enough. So it satisfies the first condition, but it has to satisfy both conditions at the same time. So we take the same set of points to the bottom equation. Is 24 plus 2 times 30 greater than or equal to 24? And the answer would be yes, which means that that's going to be the region that we have to shade. If that's the region that we're going to have to shade, then on your scratch work paper, this would be the section that I would expect to see shaded in here. Identified as it is as the feasible region. If you just write feasible region on the outside there and put an arrow in there, that would be just as fine as well. I mean, I'm not real picky about that. So if you say that this is the feasible region and you do something like this, I'm good with that. You don't have to scribble up the whole page, just as long as you're clear about what region is feasible. So that takes us to 1, 2, 3. We're halfway through part 3 of the problem, which is graphing. We're not quite done with part 3 of the problem because we have to come back and do a little bit more work. We tested the region, we found the feasible region, we found out that it was the region that was sitting out here,